Hello everyone, I'm Mengnan. Today I'll give an introduction to Tensorflow. First, let's look at some facts about Tensorflow. Tensorflow is open sourced on 9th November 2015, and it can run on a variety of platforms, like single CPU systems, GPUs, as well as mobile devices and large-scale distributed systems of hundreds of machines. And also there are some different front ends for to be used for driving the computation, like C++ and Python and R. And here is the outline of my presentation. First, let's see what is Tensorflow. Tensorflow is originally developed by the Google brand team within Google's Machine Intelligence Research Organization. And TensorFlow provides primitives for defining functions on tensors and automatically computing their derivatives. And TensorFlow is an open source.
Yes. Hello.
Hello. We can't see the slides. So this thing.
You can't see the slides. Just wait.
Yeah.
Why can't I see the slides? Oh, should I see? Okay, I guess I system is horrible. I'm gonna try it. It's almost like somewhat polished. I don't know why they can sell this. So I guess how it goes is we need to disconnect this first and then plug it back in. There's a chance that it will be able to see the slide. Can you guys see the slides now? Still know what do you see? Let me see. Why? Can you see it now? Okay, you can see it now. Good. So this may continue.
Okay. And for TensorFlow, it is an open source software library for numerical computation using data flow graphs. And first, let's see what is what is Tensor. Just like what we talked about on Tuesday presentation, and we can simply treat tensors as a multidimensional array of numbers, and a scalar is a tensor, a vector is a tensor, and also a matrix is tensor. And next, let's see what is data flow graph. I think data flow graph is the cool part of TensorFlow, and all the computation can be expressed as a data flow graph. And there are two main components of the data flow graph, and the first one is the nodes. And we can also call operations, and we can see here the weights, the input, and the biases, and the matrix multiplication, and the add, and these are the nodes and also the operations in this data flow graph. And the second component of the data flow graph is the edges, and this red line can be treated as the edges, and the edges are the n-dimensional arrays, and in other words, they are tensors. And so why we create graphs in TensorFlow, the reasons are neural networks are compute intensive, and a large one could have thousands or even millions of ways, and computing by interpreting every step would take forever. And also, so we instead create a graph made up of tensors and operations, describing the layout of the neural network, all mathematical operations, and even initial values for variables. Only after we've created this graph do we then pass it to what the TensorFlow call a session. We'll talk about session later. And this is also known as the deferred execution. And next, let's see how does the data flow work. The computations can be done in two steps. The first step is we first need to build the graph, and then second we need to execute the graph. And both steps can be done in many languages like Python, C++, and R. And for now, the best supported so far is Python. And also, Google introduced Eager, a brand new dynamic computation graph module for TensorFlow in October 2017. And here is a very simple example of how to use the data flow graph to do the matrix multiplication. And the top one is in NumPy, and the one in below is the TensorFlow. And in NumPy, we first import NumPy module, and the M1, M2 are two variables that we define, and we initialize these two matrix. The first one is the row vector, and the second one is a column vector, and we multiply them with the constant 10, and we got the output is a scalar 120. And also in TensorFlow, we first import TensorFlow module, and what we talked before, there are two steps to complete this computation. The first one is construct the graph, and we can see the M1, M2 are two variables, and we define this M1, M2 variables, and then we also define operation, that is the matrix multiplication. And then in TensorFlow, we need to call session to complete this process. That is, we define a new session, and we run this session, and we got our result. This is just a simple example of how we use this data flow graph to get what we want. And next, let's see why we choose TensorFlow. As we know, there are a lot of alternatives. There are other deep learning frameworks that we can use. So why TensorFlow? We can see there are Torch, Caffe, Theano, something like that. So I think the first reason we choose TensorFlow is that it has the largest community. And there are two figures that can prove this. The first figure is that the numbers of Stack Overflow posts. And we can see after the 2015, the TensorFlow outperforms the other three. And also in second figure, it is the adoption of deep learning tools on GitHub. And obviously TensorFlow has large users. The second reason is that TensorFlow is very portable and scalable, and it can run on CPUs, GPUs, TPUs over one or more machines, but also on phones and Raspberry. The last one is the pros and cons of the TensorFlow. And the advantage of the TensorFlow is that it is computational graph abstraction like Theano, and it has faster compile times than Theano. And also it is very convenient to use TensorBoard for visualization, and it has data and model parallelism. And the disadvantage of that is it is the speed and the memory consuming of the TensorFlow. First, TensorFlow is slower than other frameworks, and it is much fatter compared to Torch, and not many pre-trained models, and computational graph is pure Python, so that is why it is slow, and no commercial support drops out to Python to load each new training batch. Not very toolable. Dynamic typing is error prone on large software projects. That's all about that.
You say no commercial support, so how with which packages?
I think Tensorflow is pretty young framework, so compared to the other frameworks, it does not have. We cannot say no commercial support, but not many commercial support.
Yeah, it's just a question of curiosity because I don't know any of these packages have commercial support. Any of them have, because I don't think it's like Windows or some white hats that you pay for a company and they offer support. I'm not so sure about any of these Torch or like Cafe. I don't know. Maybe they have, but on top of my head, I'm not so sure about that. It's okay. Any other questions? Because everyone is quiet for this is preparing for the next presentation, I guess. So are you ready already?
Yeah, no, I'm ready.
Okay. Okay, so I guess okay. So I guess we have the second presentation then. Oh, actually, it's will be the first one. So let's see. So you're using my laptop, right?